Welcome back to another portion of lecture from Fullerton College's pre-press class. This is Professor Ben Hewitt, and we're going to carry on talking about PIA's pre-press training handbook, section 4.3, digital image basics. Now that I got that mouthful out of the way again, let's go ahead and jump back into our text and what we're talking about. We are picking it back up in the middle of talking about indexed color and why it, well, actually, the book doesn't mention why, but I can give you a brief rundown of why in a second as well. But why it exists, how it exists, and what does it mean for you when you actually encounter it, when you don't expect to encounter it, because it does still exist. It's less common now, but it's still there. So index color, unlike RGB and CMYK, which have multiple channels of color information. RGB has, remember, a red, a green, and a blue, and CMYK has 4 channels, cyan, magenta, yellow, and black channels of how much of each of those colors are going to be used to mix to make the final, either the final print if you're talking CMYK or the final visual output on your monitor if it's RGB. And each one of those pixels has a channel, each channel has 8 bits of data, which means each channel can do 256 different colors or shades of that color. So if you figure out how many colors you can produce using RGB, you have the ability to make the I got lost in thought there and derailed my train. Let's get back on and go here. Sorry. So if you multiply the channel number of possibilities in each channel by each other, you get over a number bigger than 16 million. That means that there are 16 million different combinations of red, green, and blue in their different 256 shades of light to dark that you can use, including all of them all the way on, white, and all of them all the way off, black. 16 million, and that's using 8 bits of data per channel. Index color space, you're going to have 256 colors. You get that same 8-bit data point, but instead of 8 bits per channel, you get 8 bits. You get 1 byte of data per pixel, period. That's it. So that means you're only going to get, because remember, a byte of data is, or 8 bits or 1 byte, same thing, is capable of showing you 256 variations. And if you're going to use that single channel to show you color, that means you are limited to, 256 colors, which sounds like a lot. It sounds like a real ton, doesn't it? If you imagine going to the store and buying a 256 color Crayola crayon box, by the way, my birthday's coming up in September. If you find one of those, that would be awesome. Or if you really want to go expensive, 256 Prismacolor pencils. Ooh, drooling a little bit saying it. Sorry, guys. But anyways, that's a lot of colors if you're talking about the number of those things. But when you're talking crayons or colored pencils and the number of colors in a box, you're able to mix shades between those. When you're trying to reproduce a photograph, which has really infinite numbers of interpolations of color in real life, maybe not infinite number of colors, but within a finite infinite, within the set of just a blend between green and blue, you could cut that at 1 million different steps or 2 million different steps of how many colors in between 2 colors can you make when you're mixing them and you're using the multiple, the 8 bits per channel. You got 16 million options. When you're not, you have 256 options, and it seems like a lot, but it really is not. Photos don't look right. Speaking of, I'll zoom in on this so you can see it a little bit better. Computer enhance. Okay, RGB, zoomed in on the eyeball. You can see the pixels, right? That's not a problem. That's a feature right now. You can see the pixels. Each pixel is its own individual shade of color. It's possible that more than one pixel are the same exact color, but that would be because they're the same exact color in the subject photographed. Now they see me scrolling, they hating. Let's go over to an indexed version of the same picture. This is the indexed one. Those of you old enough to remember computers in the mid-90s, remember this a lot. Everything was indexed for a while. The operating system was indexed. Computer games were indexed a lot. Like everything I did for a while looked like this. You can see there are some, they've chosen their palette carefully, is what I'm trying to say, so that there's a lot of skin tones in these 256 colors being, whoops, I scrolled badly. I am so sorry. Anyways, I was saying, you can see they were smart and chose a lot of skin tone as their different colors in their 256 colors, but it's still not enough. There's no smooth, consistent, continuous tone where it slowly melds from one color to the next. No, it looks more like a mosaic than normal. And you can see, especially in like the shading in the eyeball, not in the iris, but in the white of the eye, there's all those blues and lavenders and violets all floating in there, trying to make that shaded area that was easily done on the other side because it has infinite possibilities. So those aren't normally, or there's not enough of those present within sampling the image. If you looked at the whole picture, as the computer does of the full color version, the RGB version, you see all these millions of different possible subtle shades. But if you had to pick only 256 of your favorites to try and reproduce this using only the 256 and nothing else, well, that's literally what happened. And that's what you get over here. Like there's so many variations on the face and the skin that you have to. Your hand is forced. If you let the skin be not enough colors, it would look even weirder. So you have to spend most of that budget of colors available on making the skin correct. And then when you get into other things that are not a part of that main color scheme, you start to suffer when the budget gets stretched thin. You spent all your money on computer games and miniatures, and you're struggling to eat. Wait, that's a little too close to home, isn't it? Sorry, guys. Enough about my problems. So you have to pick your palette type when you're making index color. So the worst thing you can do, unless you're trying to show it on an old computer system, by the way, this is why index color exists, because using a full color palette with the 16 million color possibilities, that uses a lot of memory, both in the storage type memory, your ROM, the stuff that's the chips you purchase and stick in your computer that is where you store things in your gigabytes and terabytes of data storage on hard drives, or in your RAM, which is your temporary short-term memory that remembers what the computer needs to know to show you, the user, the picture in real time as you scroll through your pages. Both of those take a lot of information, and I grew up where 30 megabytes would be the size of your computer hard drive if you upgraded it. Now, most of the files I work with are bigger than that. Most of my files are bigger than the computers I used to use. In fact, there was a computer game I used to play when I was younger, when it first came out, and it was an online game, and it would send updates every once in a while as they updated the game and made it better. And I was able to play for like a year, and then all of a sudden, one of the updates came through that was bigger than my hard drive, and I was done. Like, well, the update itself is bigger, and we're through. So, anyways, computers didn't always have the same amount of system available. You didn't have the memory, so you had to tailor it down to make it smaller. So, anyways, you can choose the Mac OS color palette or the Windows color palette, and that'll choose the 256 colors that the desktop normally use to show you its icons. And I mean, again, we're spoiled, and nowadays you have full color images. If you're using the Mac OS, and it's like sand dunes, they show them during the same time of day that it currently is, and that's a lot of memory that's wasting to be cutesy. In the old days, Mac would just give you a gray or a blue violet background, and Windows will give you something similar, often that weird Windows teal. But anyways, those are different color palettes from each other, and that would be a palette you could choose as your index color palette. Or you could choose one where Photoshop picks it out itself. And in the picture we just saw of the two eyeballs, that's more like the Photoshop picking it. Because again, instead of using all the weird system ones, and I might have to do a demo of this. I think we're heading that way in a moment here, aren't we? It's inevitable. I can't stop it. We're caught. It's pulling us in. So here we are back in Photoshop looking at our friendly neighborhood Spitfire Mark 5B. So let's go ahead and zoom in a little bit here. So you can see enhance. Sorry, I'm still making fun of that. You can zoom in and look at the JPEG. I know there's a little bit of compression in the JPEG, which we'll talk about again later, but overall, as you're looking at the individual pixels that make up this airplane, You can see that they're all individuals. I'm not, shh. But every single one has its own individual color. And yeah, you can see how big the pixels are when you zoom in, and sometimes there's some compression issues here and there. But overall, what you see or what the camera saw is what you get. The image shows you everything as it should be with all the variations of each individual color on there for now. So let's go ahead and try some things here. We're going to go up to image mode, index, and I'm going to switch this to one of the worst possibles here and hit System Windows. Here it comes. You probably didn't notice a difference based off how good these videos actually end up being, but let me zoom in for you. This is using the Windows OS color palette, and now you can start to see that it's built out of colors that it's not made out of. In fact, it tries to do a bit of a pointillism or halftone kind of thing, where in order to do a gradient from one color to another, it uses more of a color or less of it. But let's look at some of the extremes where it really falls apart, because it had overall the Spitfire is, if you zoom out far enough, you don't notice a problem. It's made out of only a few colors. The sky is mostly that one color. It's a slight gradient. And the airplane's made out of a sea gray and a dark green. And then they have the different colors for the roundels and the markings. When you zoom in on it, though, you can start to see that it, look what it did to the roundel here. The red and blue circles on the wing are like wonky. It's polka dot. Because it doesn't have enough blue to show the proper tone, it's using dots of blue emitting dots of a similar gray color to try and approximate it from a distance. Okay, I undid it. So zoom back in. This is how it should have looked. And this is how it did look. Before, after, before, after. That's the effect of indexing to the extreme. Let me show you a slightly less crazy index. Back to full screen, image mode, index color, and we're going to choose local, and we'll use selective or perceptual. Let's try perceptual. Doesn't really matter which one we used. Let's go. So now if you zoom in, it is now, instead of choosing the colors it's going to show you based off of what the standard default 256 colors Windows prefers is, now we're seeing 256 colors taken from this picture. So now it still did some stuff, but if we zoom in on like the roundel, again, those circular markings on the wing here, that looks a little bit less silly now, doesn't it? And the gray and the green camouflage, that's a bit more correct. In fact, if you really want to find a problem, you have to look out in the sky as it slowly dithers from one color to another. And if we zoom in, you can kind of see that it's a speckled sky now made out of 3 or 4 different shades of bluish lavender that kind of speckle more or less from one to the next as it scrolls through. And up here at the top of the sky, it's got kind of a beige gray to it to try and approximate the colors that it was showing you. Good on you, Photoshop, for being able to do all this, by the way. So we're back to finish out here talking about indexed color mode. Sorry, I took an entire video to talk about it, but it's an interesting concept. In Photoshop, here's the thing, it shows it to you. Oh, I forgot to show you when I was in there. Bad teacher. Sorry, guys. Anyways, the channels switch from being RGB or CMYK to just being index. Index is the name of the channel because the index is just the only colors it's using. And that is indexed color. After this, we're going to start talking about CIE, or C as it's called, if you kind of try to pronounce the CIE acronym, C Lab Color. And C Lab Color is not something I want to introduce within the last minute of a video. So until next time,